Hello everyone, welcome back. So in this video we are going to understand the partition array for the maximum XOR and AND. So we have already uploaded the first part of this video, but I'm thinking to have some more visuals so you can understand clearly. I'll try to cover all the logic and the concept so we can understand how to implement it and why we are implementing like this. Okay, very first, can we say uh, what we have given? We have given an array that is called nums, right? And we need to partition the array into three non-overlapping subsequences. Can we say that? These two things we have given, right? And we need to partition this array into what? In three non-overlapping subsequences A, B, C, we can say that. Every element of nums must go into exactly one, either A, B, or in C, right? So A, B, C can be empty. Any of these can be empty. All of them can be empty. Okay. Then we need to compute the expression XOR A and B XOR C, right? And we have to return the maximum value of this expression over all the possible valid partition. I hope you understood the problem. Now understood the XOR. So this is a exclusive XOR, right? So can we say if we apply the XOR on this array, right? 2, 3, and 1. Can we say that 2, 3, and 1 is equal to 0, right? This example we have already seen the first part of the video. Okay. But if you remember, we have took what? We have converted into binaries and then we have to apply this XOR, right? And we have seen that we got the 0. Similarly, we have bitwise operator and, right, where we will pass this array and we are seeing that we are getting 1, right? So these things we have already understand what is XOR and what is AND. If you're not watched, please watch first part of video. In the very initial part, we have already discussed this. Okay. Now what you need to do, we need to try all the ways to assign each number from A to B, B to C, like that, right? Means for each number we have to assign. So either we'll assign into A or B, or A to B, or B to C, right? Like that we have, or either one of them is can be empty, right? So all the ways we will try. Why? To maximize this expression, right? It means the problem says that we have to maximize the expression, that is this, right? And these are the partitions of the array. So each element belongs to exactly one of them. So in simple term, this is the problem we have, right? We have to maximize this where A, B, C are the partition array of the given array. Okay. So I hope till now you have understood, right? So this is the problem we have given, right? Means we have given this expression we have given, right? And these are nothing but the partition of the array. So we have seen this example where we have took the input 1, 2, 3 and we have seen that partition. So let's call, if we partition this array, the possibility that we individually put each element into A, B, C, right? And if we'll apply the XOR, we'll say we are getting this 1, 2, 3, and if we'll do sum of all these, we'll get what? 6. And that is why we are saying here is a maximum achievable is 6. Partition ways 2, if we'll apply, where we'll take 1 and 2 from this array in A, B will not take anything, and C will take only 3. Okay. If we'll apply this formula, we'll get 3, 0, and 3. We'll do the sum of all this, we'll get 6. In both cases, we are getting what? Maximum achievable is 6. And so the output is 6, we can say. Okay. So let's understand the approach overview, right? So in the brute force approach, right, if you apply the brute force approach, means very simple approach, right? Means we have to do what? For all the subset partitions, right, we'll use the bitmask, right, where the total subsets is 2 to the power n, right? Either you will choose it or not choose it. It's okay. So total partition will be 2 to the power n. right? Means if n we have some value, it will be 2 to the power n, right? Means subsets that we have understood. So for each subset that is called mask, right, we'll consider it as A, and we will pre-compute two things, XOR A, and will take XOR 1 will take the mask. This mask is nothing but the partitions subset, right? If we'll apply this, right, this XOR mask, right, will compute what? The XOR A, right? And the remaining element will form B union C, right? So we'll try to maximize XOR C plus AND B, or AND B plus XOR C. Can we say that? Means very first in the brute force approach, what we will do? We will try all the partitions subsets, right? Using the bit mask, right? So the total subsets is how many subsets we have? 2 to the power n subsets we have, right? So for each subset mask, so for this we can say, because we are using the bit mask, right? So we can say for each subset that is called mask, okay? So either you are writing one subset, right? Two subset, three subset, or 1, 2, right? So those are nothing but your subset. So each subset is a mask. So consider this as a mask is A. So if we'll pre-compute XOR at A means what? The mask XOR 1 at mask. We can say that, right? Remaining element will form B union C. Means we want to maximize XOR C plus AND B, or AND B plus XOR C. I hope you understand the problem. Very first step, what we need to do, we will pre-compute the XOR, then we'll use the XOR basis, and then we'll maximize the result. How? Very first, we'll do the XOR mask, right? Where we'll store the XOR of element in subset mask, and then we will do what? AND mask. Means for this mask is nothing but your subset, okay? Each subset is called mask, okay? So if we apply the XOR 1, we have to find the XOR 1 at mask A, right? Means we want the XOR of elements in the subset mask, in a subset. Leave the name mask right now. Just think the XOR of elements in the subset is will have in this XOR 1 at mask. Can we say that? I'm just saying you don't get confused, right? Just use the subset, okay, for now. And this subset is nothing but the mask you are representing, okay? I hope you understand. Very first, what we need to do, we'll pre-compute the XOR, okay? So this XOR will pass the mask. This mask is nothing but treat as a subset, okay? Means all the elements in the mask or subset. Then we'll apply the AND, means AND of the element, right, in the subset. That will pre-compute all of this. So we'll use XOR basis here, right? So for each mask, we will use the XOR basis on the element in A to compute the max XOR subset, right? Means if there is some element in A, right, how we are going to compute, right? We have to compute the max XOR subsets, right? So this concept we'll use as a XOR basis. So XOR basis on the elements in A to compute the what? XOR max XOR subset, right? From the remaining bits. That is what? Nums at J, and we'll take what? AND, right? Now we will store the result like this. So 2 we get from the value we have already calculated this. We'll multiply 2 into max XOR subset, right? If you have seen the previous part of the video, you can understand the code how we have done that, right? We have make the code here. Now we have to maximize the result. So for each mask, we have to find the what? Complement subset, right? Because we have to find the maximum sum. So for each mask, we have to find the complement subset elements in A as a potential B, right? And to maximize this, you should have these two things, right? XOR2 of the mask and complement, right? Means for each mask we will find the complement of subset, which is the element is not in it, right? Because this is potential B. Okay, and so we'll do the plus and we'll get the maximizer, right? Math.max that you have seen, right? So in this case we'll get what? O of n into 2 to the power n. We'll pre-compute this value. So pre-computation, we are using this, right? And the main loop, so it will take the n into 2 to the power n, right? And this is efficient due to bit masking and compact XOR basis. Now understand, so we are doing what? All subset partitioning using what? Bit masking, right? So total is how many? 2 to the power n subsets. Can we say that? So when we are calculating all the subsets partitions using what? Bit mask, means total subsets we have with this one, right? So when we have given this array, let's suppose nums having length n, so each element can either be included or not included. That is why it become what? 2 to the power n subsets, right? It means, so for every element there is two choices. Either you will include or not include, exclude you can say. And so the total number of subsets is what? 2 to the power n. That you understand? Means all the subsets partition that we are doing using the bit masking is 2 to the power n. Why? Because we are either will choose each element or will exclude it. Now understand the bit mask. So a bit mask is a n-bit binary number where 1 represents the element at that position that includes and 0 means it excluded. So for all nums, let's suppose call A, B and C, how many elements we have? 3 elements we have. So 2 to the power 3 means 8 subsets we will make, right? Means bit mask from 0 to 7. For each element we have to take the bit mask. Okay, the number of elements you have, and for each element you need to do what? 2 to the power n. So n is what? 2 to the power 3 and it will get 8. The total bit mask will start from 0 to 7. Let's understand how. So 2 to the power n is 2 to the power 3 is 8, gives you the bit mask 0 to 7. So let's call 0, 1, 2, 3, 4, 5, 6 and 7. So each bit mask, if you represent in binary, it can represent it like this. Can we say that? We can represent this. So if you'll take the subset, very first all are 0, we'll take empty, and then we'll take what? The subset is C, B, BC, A, AC, AB, ABC. So these are the possibilities we can get, right? Where it is coming, here C is coming, because how many elements are there? A, B, C. So this is 0, this is 0, this is 1. So we'll take C here. This is coming what? 0, 1, 0. So this time what we will take? 0 is this 0, this is 1, this is 0. We'll take B. Understood? So this is the concept of bit masking. I hope you understand. Here we are getting what? 0, 1, 1 means A is 0, but B and C is having 1. So we'll take these two subsets. So like this, we will create a subsets. Okay. So this is the gap I have not told you in the previous part of the video. So I may skip that. And so you have not understood the video. Okay. Only because of this part, making you the understood of the subset, right? I have created this video. Okay. But it's okay. Sometimes happens. Let's understand how in this case, if we represents the bit mask from 0 to 7, how we will calculate the in the code, right? So let's suppose if you have n you are getting, right? How will you get the n? Nums dot length, right? So you will start your for loop 0 to the bit mask. Mask is less than equal to what? You will take the shift 1 shift n. Okay, till that we will make the loop. Okay, then we'll take a list. Okay, subset, and we say that it equal to new array list, right? So let's understand the mask that start from 0, right? You know how this works, right? Let's suppose I'll call it 1 left shift n. So if this 1 this n is having value what? 3. It means it will represent at what? 2 to power 3, right? It means how many it will go? Till 8 it will go. Because this is a what? Left shift operator, right? And this left shift operator shifts the binary 1 to the left by n bits, correct? How many bits? N bits. So let's understand here. Okay, so can we say in binary what is n? In binary it is 0 0 0 1. Can we say that 8 4 2 1, right? If you represent all are 0, 1 is there, right? So we'll represent like this. Now with 1 we have to shift what? Shift 3 means we have a left shift operator, right? Means we will shift the binary 1, right, by how many bits? 3 bits. Can we say n bits? You can say it is 3 bits. In this, if you represent this, how it will be what do you call shift? It will become 0. 3 bit will come. It will become 0 0, but it will become 1. So 3 bit we have shifted. How many bit we are shifted? One from here to here. This 3 bit. And in decimal this represent as what? 8, and it is in decimal 8 number, right? This is why if you call, if n, we have n is let's suppose 3, right? Means total number of subsets is what? 8, right? Why? Because this way we will calculate it, total number of subsets. If the set of size is n equal to 3, so we'll get 8. I hope you understand, right? Okay. So mask will start at where? At 0. Then mask should be less than what? This is nothing but 8, right? Mask plus plus. So we'll create each time a subset, right? We'll create a subset. Only we'll keep adding the subset here, right? When for all we are making what? For all loop, for all the value I is 0, I should be less than n, I plus plus. We go for all the n means 3 times. So outer loop will go what? 8 times, but inner loop will go what? 3 times, because 3 elements we have. So each element will check here. Each element of the nums will check should be included or should not be included. So when we will include it, we will add into what? Into the set subset. I hope you understand, right? I told you there is every element of the nums 1 2 3. Either we will include into the set or in the subset, or will not include it. So if let's suppose very first we have included all of them in all subset, the next time maybe I will take these 2 and will this. So maybe the third subset will not be, we are going to add, right? So those concept will arise here. How? You will have some value, right? You will take the AND operator, right? And you will take the left shift. What is coming here with the 1? So anything is coming here. If this is not equal to 0, means some value should come. Okay? If the value should come, means we will include into the subset, right? And then we can process this subset further. I hope you understand, right? Means I told you how we'll represent the bit mask. If we have n is equal to 3, we are getting what? How many subset? 8 subset, and bit mask from 0 to 7. So if we represent the bit mask, that we can 0 to 7 binary in this, and this subset will include like this. Now if we have, let's suppose A, B and C, 3 elements we have, all are coming 0 0 0 0, means it will be empty. We are not passing anything as a subset. Okay, if we have 0 0 1, means this one this C will be on, so we'll add into the where and the subset, and that we will do here. Will either add or will not add. That depends on who? This condition, if condition. So why this helps? So you can try all these possible combination of element in one group. Let's say A, using the bit mask. Then we'll use the complement of the mask to divide the rest into B and C. I hope you understand what we are trying to do. You should try what? All the possible combination of element for one group. Let's say that group is A, right? How? By using the bit mask, right? Then we should use, then we'll use the complement, right? If you remember, sum of three number, sum of two numbers, you know the problem, right? Sum of two number. There will be a tree, what do you call? There will be an array, right? An array contains two elements. Let's suppose 2 and 7, 5, 3, like this. And target is what? 9. So these two elements is already present. There is another question is three element. The three element will be available. So first two will do the sum and we'll take the complement and we'll check the complement. Like that we are used to doing, right, in the that problem. If you remember, if you not remember, leave it. So that time we will use the complement, right? So that complement of that mask will divide the rest of into B and C, right? Let's suppose I want to find 9, right? But I got 2, 5, 7 and not 9 and 4, let's suppose, or 11, we can take 11. Okay, so if target is 9, if we are iterating over it, so what we'll do? 9 minus 2 will 2, what is called 7. So this is called complement. We'll check further 7 is available here or not. So it is available further. So we'll say this index and this index, right? I hope you understand this problem, right? Like that we will find first of all this all group A. We'll try all the combination and we'll try to find it, right? Then we'll take the complement of that mask and we'll divide through the B and C. Now understand the approach using the bit mask. So we have given what? Array we have given, whose length is n. And you need to partition into 3 disjoint sets A, B, and C. Means we want to maximize this one. So we will use the bit masking to represent the subset A. How? For each mask, we'll go from 0 to 2 to the power n minus 1 that represent the possible choices of subset A, right? And each element which is not in the mask A will go into remaining set. I hope you understand, right? So this is the purpose. We will use the bit masking, right, to represent A so that we can form the subset A, right? And which is not in the subset A, it means it will go automatically in remaining set. Okay. So very first we'll pre-compute all the subset, right? How we are going to do that? Very first you will define the XOR at 1, right? And we'll take the shift of the number of elements that we have given that you can get, and you can define the size, and you will operate like this. We have seen that how to do that, right? And each time will include into XOR value, right? This is the what you call, forget the name, the subset of A, right? So subset of A will keep storing here. How? We'll calculate the XOR value and we'll keep storing here. I hope you understand this pre-compute, right? Now for each mask A, let's call it a current, right? And we have a current mask. Current mask is known as A mask. Okay, so the element not in A, right, is called what? The rest of the element, that is called rest mask. If you take the complement, you can get it, right? Now we'll need to partition the array into rest of the mask B and mask C, right? How we can get it? You can get it like this. You just either this or this, you can get the rest mask. Whether B and C, you will get the disjoint sets, right? So we'll iterate over this and we need to partition this what you call this rest for the mask B and mask C, like this, right? We need to partition this, the rest of this. This is the rest mask. So this rest mask should be converted into two things: the this mask and C mask, B mask and C mask. That is called the, you can get from here. Okay, I hope you understand. We iterate over all the subset of mask as possible as B. I need to drink water. Okay, so let's almost it's finished. Okay, we tried over all the submask of rest mask that is possible B, right? So how we can do that? We can get the B mask from the rest, and we'll take the B mask which is it is greater than 0. We'll keep getting how mask minus 1 and then the rest mask. If we'll operate these two together, you will get the value. Okay, and then you will get similarly we'll get the mask C, right? And you will find the total. You know how to find the total, right? You just need to take this, you know, this value and this two value, and this total is you got the total. Once you got the total, just take the max. This thing we have already discussed, but I thought to discuss more so that you can understand. So you can promote so you can pre-compute this for all the subset similar to the XOR that we can do that, right? So if you understand this, you can do for this one also. I have already explained in the first part of video. You can see from there. Otherwise, this video will also become 50-minute video. And I think, okay, so this is the summary of the variable. Okay, I think we have covered everything now. So what is the XOR basis? You should understand, right? We have already seen this. By XOR basis, we have seen this. So let's summarize this first, right? We will first create all the subset of A using the bit mask, and for each A, we'll take what? We'll get the rest, which is not in the A, then build the XOR basis for the rest. We'll generate all the XOR C from the basis, and then we'll get what? B minus B will get from rest minus C. And then you can maximize the value. Okay, please must watch the first part of the video, otherwise it will be difficult to understand this video also. Thank you guys, thank you for watching this video. I hope you will like this video, and I'll see you in the next one. Please subscribe this channel, like this video, and directly or indirectly support ExpertFunda. So I'll keep